All right, these are the answers to the review for the factoring quiz. First one's just want us to pull out the greatest common factor. What can divide evenly into 5 and 20? That'd be 5. And we have 5 w's that can be pulled out. So that leaves us with w squared minus 4 left over. Now, if we wanted to go a little further, w squared minus 4 could be factored into w plus 2, w minus 2. So this is good, this is even better. Here, I gotta find a number that divides evenly into 15, 24, and 33, and that would be 3. There's 3 A's, 4 A's, 2 A's, so I can take at least 2 A's out. 2 B's, 5 B's, 3 B's, I can take at least 2 B's out. Okay. So 15 divided by 3 is 5. There were 3 A's, we took 2 out, 1 would be left. Had 2 B's, took them out, that's all that's there. Negative 24 divided by 3 is negative 8. We had 4 A's, took 2 out, 2 left over. Had 5 B's, took 2 out, there's 3 B's left over. 33 divided by 3 is 11. Had 2 A's, took them out. Had 3 B's, took 2 out, there'd be 1 B left over there. Okay. Now factoring polynomials, we're looking for 2 numbers that multiply to equal the back and add to equal the middle. In this case here, that would be positive 7 and a negative 4. 7 times negative 4 is negative 28. 7 plus negative 4 is positive 3. Here I'm looking for 2 numbers that multiply to equal negative or 35 and add to equal negative 12. Those numbers are negative 7 and negative 5. Negative 7 times negative 5 is 35. Negative 7 plus negative 5 is negative 12. Here I'm looking for 2 numbers that multiply to equal negative 14 and add to equal 1. You can search all day. Not going to find them. This is an example of something that does not factor. Okay. It's a fine equation, we just aren't able to factor it. Here, if I'm looking for 2 numbers that multiply to equal negative 12 and add to equal negative 11, I can look at negative 12 and positive 1. Negative 12 times 1 is negative 12. Negative 12 plus 1 is negative 11. Here I'm looking for 2 numbers that multiply to equal negative 64, add to equal 0. That would be 8 and negative 8. 8 times negative 8 is negative 64. 8 plus negative 8 is 0. Number 8, looking for 2 numbers that multiply to equal negative 19 and add to equal 18. That's 19 and negative 1. 19 times negative 1 is negative 19. 19 plus negative 1 is 18. Number 9, I'm looking for 2 numbers that multiply to equal 15 and add to equal negative 8. Those are negative 5 and negative 3. Negative 5 times negative 3 is 15. Negative 5 plus negative 3 is negative 8. Here I'm looking for 2 numbers that multiply to equal 36, add to equal 12. Those numbers are 6 and 6. Okay. 6 times 6 is 36. 6 plus 6 is 12. Because they're the same, if we wanted to, we could write this as q plus 6 squared. The choice is ours. For number 11, we're going to pull out a common factor. They're all divisible by 5, so we'll pull that 5 out first, of x squared plus 9x plus 14. Now I'm looking for 2 numbers that multiply to equal 14 and add to equal 9. Those numbers are 7 and 2. 7 times 2 is 14. 7 plus 2 is 9. So this would be our full factoring right there. Same thing here, I see they all have an h, so I'm going to pull that h out of h squared plus 2h minus 24. So I'm looking for 2 numbers that multiply to equal negative 24 and add to equal 2. All right, those numbers are 6 and negative 4. 6 times negative 4 is negative 24. 6 plus negative 4 is 2. Here I'm going to pull a 10 out of them. I'll have p squared plus 11p plus 30. I'm looking for 2 numbers that multiply to equal 30 and add to equal 11. All right, those numbers are 6 and 5. 6 times 5 is 30. 6 plus 5 is 11. There's our full pad. Over here, I'm going to pull a 3 and a w out. That's going to give me w squared minus 7w plus 12. I'm looking for 2 numbers that multiply to equal 12 and add to equal negative 7. Those are negative 3 and negative 4. Negative 3 times negative 4 is 12. Negative 3 plus negative 4 is negative 7. For number 15, I'm looking for something that divides evenly here. I can pull a 6 out and I can pull a p out. I'll have p squared minus 25 left over. Well, p squared minus 25 can be factored into p plus 5, p minus 5. 5 times negative 5 is negative 25. 5 plus negative 5 is 0. And then 16, I've got p to the 4th minus 81. So p to the 4th is p squared times p squared. 81 is 9 times 9. So this factors into p squared plus 9, p squared minus 9. Okay, and that's good to start. But then if you look at p squared minus 9, that's p times p, 3 times 3. So you could keep going with that. You could make that p plus 3 and a p minus 3. And that'd be okay there. All right, 17 says we have a rectangle, an area of x squared plus 8x plus 15, and one side is x plus 5. I want the other side. So I know that this times this has to give us this, right? So if I look, x times x would give us the x squared. 5 times this would give me 15. So this must be 3. Just to check, 5 plus 3 is 8. And absolutely, our other side there is x plus 3. Same thing on 18, we've got a rectangle, y squared minus 3y minus 40. One side is y minus 8. So again, this has to be y times y would give us the y squared. But now the negative 40 is negative 8 times this, which would then have to be positive 5. 5 times negative 8 is negative 40. If I add them, net 5 plus negative 8 gives me negative 3. So this checks out. Now they're asking for the perimeter, so I want the distance around this. So if I throw in all 4 sides, I have y, that's 4 y's. And then negative 8 plus 5 plus negative 8 plus 5 is a negative 6. Then our last one here says, when Henry factored this expression, he remembered that the two factors were exactly the same. So when he had w squared plus 6w plus this something, it factored into exactly the same thing, the exact same numbers. Well, we know that these numbers have to add to give us the middle. So if these are the same and they add to give us 6, they both must be 3. So we know what the factors were. And if they were both 3, then 3 times 3 would give us 9. That must be the mystery number right there.